Grounding conductors are not properly bonded together. The bonding screw is missing and the conductors are simply twisted together. This is a safety hazard as it can create a loose connection that can lead to electrical arcing and fires. It's imperative that grounding conductors are properly bonded to ensure a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protection devices like circuit breakers or fuses. A bonding screw, or an approved grounding connector, must be used to securely connect all grounding conductors within the electrical box. Simply twisting the wires together is insufficient and does not meet the requirements of the National Electrical Code, or NEC. The remodel box is not securely screwed to a stud. It is only attached by one screw, which is not enough to support the weight of the box and the devices that will be installed in it. This can lead to the box pulling away from the wall and creating a dangerous situation. Electrical boxes must be securely mounted to provide a stable and safe enclosure for electrical connections. The NEC specifies methods for securing boxes, including using appropriate fasteners and ensuring adequate support based on the box size and the devices it will contain. In remodel situations where access to studs is limited, specialized remodel boxes with integrated mounting mechanism should be used, ensuring a firm and reliable attachment to the wall. Drywall covers part of the remodel box. This is not allowed by the NEC as it can make it difficult to access the box for maintenance or repairs. Electrical boxes must be readily accessible for inspection, maintenance, and repairs. Covering the box with drywall violates this requirement and can create a safety hazard. The NEC mandates that the front face of the box must be flush with or project from the finished surface of the wall or ceiling, ensuring easy access without requiring demolition. The work in this image is of poor quality and does not meet the standards of the National Electrical Code, or NEC. It is important to hire a qualified electrician to perform electrical work to ensure safety. Electrical work should always be performed by a licensed and experienced electrician who is familiar with the NEC and local codes. Improper wiring can lead to electrical shocks, fires, and other hazards. Firstly, grounding is a critical safety measure in electrical systems. Its purpose is to provide a low impedance path for fault current to return to the source, allowing overcurrent protection devices such as circuit breakers and fuses to quickly interrupt the circuit in the event of a ground fault. This helps prevent electrical shock hazards and reduces the risk of fire. The grounding system consists of several components, including the grounding electrode conductor, the equipment grounding conductors, and the grounded conductor neutral. Each of these components plays a specific role in ensuring the safety and proper functioning of the electrical system. Secondly, bonding refers to the connection of all non-current carrying metal parts of an electrical system to create an electrically conductive path. This includes metal enclosures, raceways, and equipment frames. Bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. Proper bonding also helps to reduce electromagnetic interference and improve the overall performance of the electrical system. Thirdly, the National Electrical Code, or NEC, is a set of standards for safe electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, bonding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property. Fourthly, electrical boxes are enclosures used to house electrical connections, such as splices, terminations, and devices like switches and receptacles. They provide protection for the connections and prevent accidental contact with live wires. Electrical boxes are available in a variety of sizes and materials to suit different applications. They must be properly installed and supported to ensure their structural integrity and prevent them from becoming a safety hazard. Fifthly, wiring methods refer to the types of cables and conductors used in electrical installations as well as the methods used to install them. Common wiring methods include non-metallic sheaths cable Romex, metal-clad cable MC, and electrical metallic tubing EMT. Each wiring method has its own advantages and disadvantages, and the appropriate method should be selected based on the specific application and the requirements of the NEC. Sixthly, overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They work by automatically interrupting the circuit when the current exceeds a predetermined level. Overcurrent protection devices are essential for preventing electrical fires and protecting equipment from damage. Seventhly, electrical safety is paramount. Working with electricity can be dangerous, and it is important to take precautions to prevent electrical shocks, burns, and other injuries. Always to energize circuits before working on them, use insulated tools, and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. Eighthly, the grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a path for fault current to dissipate into the earth, helping to protect against electrical shock. The size and type of grounding electrode conductor are specified in the NEC and depend on the size of the electrical system. Ninthly, equipment grounding conductors are used to connect the non-current carrying metal parts of equipment to the grounding system. This includes metal enclosures, raceways, and equipment frames. Equipment grounding conductors provide a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly interrupt the circuit in the event of a ground fault. Tenthly, the grounded conductor, or neutral, is a current-carrying conductor that is intentionally grounded at the service entrance. The grounded conductor provides a return path for current under normal operating conditions. It is also used to provide a reference point for voltage measurements. It is important to note that the grounded conductor is different from the equipment grounding conductor, which is used to provide a path for fault current. When installing electrical boxes, it's crucial to ensure they are securely mounted and readily accessible. The NEC specifies that boxes must be supported independently of the conductors they contain. For new construction, boxes are typically nailed or screwed directly to studs or joists. In remote situations, specialized boxes with integrated mounting brackets are available. These brackets allow the box to be securely attached to the wall without requiring access to a stud. Furthermore, the NEC requires that the front edge of the box be flush with or project beyond the finished surface of the wall or ceiling. This ensures that the box is readily accessible for maintenance and repairs. Covering the box with drywall or other finishing materials is a violation of the code. Regarding grounding and bonding, the NEC provides detailed requirements for ensuring the safety and proper functioning of electrical systems. All grounding and bonding connections must be made using approved methods and materials. Grounding conductors must be securely connected to the grounding electrode and to all metal parts of the electrical system. Bonding jumpers must be used to connect metal enclosures, raceways, and equipment frames to the grounding system. It's important to avoid creating ground loops, which can cause unwanted current flow and interference. A ground loop occurs when there are multiple paths for ground current to flow, creating a circulating current that can interfere with sensitive electronic equipment. To prevent ground loops, ensure that there is only one path for ground current to return to the source. When working with electrical wiring, it's essential to follow all safety precautions. Always de-energize circuits before working on them, using a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Use insulated tools to prevent accidental contact with live wires. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is adopted by most states and local jurisdictions in the United States, and compliance with the code is essential for ensuring the safety of people and property. To ensure compliance with the NEC, it's important to understand the code's requirements and to follow them carefully. The NEC is a complex document, and it can be difficult to interpret. If you have any questions about the NEC, consult with a qualified electrician or electrical inspector. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. These codes and regulations may be more restrictive than the NEC, and it's important to be aware of them. Contact your local building department or electrical inspector to find out about any local codes and regulations that apply to your project. Hiring a qualified electrician is the best way to ensure that electrical work is done safely and correctly. A qualified electrician has the training, experience, and knowledge to perform electrical work in accordance with the NEC and local codes. They can also identify potential hazards and correct them before they cause problems. When hiring an electrician, check their credentials and make sure they are licensed and insured. Ask for references and check them carefully. Get a written estimate before the work begins and make sure it includes all costs, including labor and materials. Be sure to review the work carefully before paying the electrician. If you are not satisfied with the work, discuss it with the electrician and try to resolve the issue. If you are unable to resolve the issue, you may need to file a complaint with your local building department or consumer protection agency. Remember, electrical safety is paramount. Take the time to learn about electrical hazards and how to prevent them. Follow all safety precautions when working with electricity. And if you are not comfortable working with electricity, hire a qualified electrician. Let's discuss some specific examples of electrical wiring mistakes that can lead to safety hazards. One common mistake is using the wrong size wire for the circuits. The NEC specifies the minimum wire size for each circuit based on the ampacity of the circuit breaker or fuse. Using a wire that is too small can cause it to overheat, which can lead to a fire. Another common mistake is improperly splicing wires. All splices must be made inside an electrical box and must be properly secured using wire connectors. Loose or improperly made splices can cause arcing, which can also lead to a fire. Overloading circuits is another common mistake. Each circuit is designed to carry a certain amount of current. Overloading a circuit can cause the circuit breaker to trip or the fuse to blow. It can also cause the wires to overheat and potentially start a fire. Using extension cords improperly is another common safety hazard. Extension cords are intended for temporary use only. They should not be used as a substitute for permanent wiring. Extension cords should be properly sized for the load they are carrying and should not be run under rugs or furniture, where they can be damaged or overheat. Damaged electrical cords are another safety hazard. Cords with frayed insulation or exposed wires can cause electric shock or fire. Damaged cords should be replaced immediately. Tampering with electrical equipment is extremely dangerous. Never attempt to repair or modify electrical equipment unless you are qualified to do so. Electrical equipment should be inspected regularly for damage or wear and tear. Faulty electrical equipment should be repaired or replaced immediately. Improper grounding is a serious safety hazard. All electrical equipment must be properly grounded to protect against electric shock. Grounding provides a path for fault current to return to the source, allowing the circuit breaker to trip or the fuse to blow. Using unimproved electrical products can also be dangerous. All electrical products must be approved by a recognized testing laboratory, such as Underwriters Laboratories UL. Approved products have been tested to meet safety standards and are less likely to cause electrical hazards. Ignoring warning signs of electrical problems can also lead to safety hazards. Warning signs of electrical problems include flickering lights, burning smells, and sparking outlets. If you notice any of these signs, investigate the problem immediately and take corrective action. In addition to these specific examples, there are many other electrical wiring mistakes that can lead to safety hazards. The best way to prevent these hazards is to hire a qualified electrician to perform all electrical work. A qualified electrician has the training, experience, and knowledge to perform electrical work safely and correctly. Remember, electrical safety is paramount. Take the time to learn about electrical hazards and how to prevent them. Follow all safety precautions when working with electricity. And if you are not comfortable working with electricity, hire a qualified electrician. Now let's delve into some specific aspects of electrical box installation and grounding, referencing relevant sections of the NEC for clarity. Regarding box fill, NEC section 314.16 specifies the maximum number of conductors, devices, and equipment permitted in an electrical box. This is crucial to prevent overcrowding, which can lead to overheating and insulation damage. The box fill calculation takes into account the volume of the box, the size and number of conductors, and the presence of devices like switches and receptacles. It's essential to perform this calculation accurately to ensure compliance with the NEC. For conductor types and ampacity, NEC section 310.15 provides tables that list the allowable ampacities of various conductor types based on their size, insulation, and installation conditions. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. Using conductors with insufficient ampacity can lead to overheating and fire. The choice of conductor type depends on the application and the environmental conditions. For grounding electrode systems, NEC section 250.50 and subsequent sections outline the requirements for grounding electrode systems. A grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode for ground. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage and provide a path for fault current to dissipate. The NEC specifies the size and type of grounding electrode conductor based on the size of the service entrance conductors. For bonding of metal enclosures, NEC section 250.92 specifies the requirements for bonding metal enclosures, raceways, and equipment frames. Bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. Bonding jumpers must be used to connect metal enclosures to the grounding system. The size of the bonding jumper depends on the size of the circuit conductors. In the context of kitchen remodels, it's important to pay close attention to the requirements for ground fault circuit interrupter, or GFCI, protection. NEC section 210.8 requires GFCI protection for all receptacles serving kitchen countertops. GFCI protection is also required for receptacles located within 6 feet of a sink. GFCI protection is designed to protect against electric shock by detecting small imbalances in current and interrupting the circuit. When installing new electrical boxes in a kitchen remodel, it's important to choose the right type of box for the application. Non-metallic boxes are commonly used in residential wiring. Metal boxes are also used and must be properly grounded. The box must be sized appropriately for the number of conductors and devices it will contain. The box must also be securely mounted to the wall or ceiling. When running new wiring in a kitchen remodel, it's important to follow all NEC requirements for wiring methods. Non-metallic sheath cable Romex is commonly used in residential wiring. The cable must be properly supported and protected from damage. The cable must also be properly terminated at the electrical box. It is vital to remember that electrical work can be dangerous, and it's important to take precautions to prevent electrical shocks, burns, and other injuries. Always de-energize circuits before working on them, use insulated tools, and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. Also, note that local codes and regulations may vary from the NEC. It's important to check with your local building department or electrical inspector to find out about any local requirements that apply to your project. It's also worth emphasizing the importance of proper wire connections. All wire connections must be made inside an approved electrical box. The connections must be tight and secure. Wire connectors, such as wire nuts, must be used to connect the wires. Electrical tape should not be used as the primary means of connection. Another crucial aspect is the proper identification of conductors. The NEC requires that all conductors be properly identified. The grounded conductor neutral must be white or grey. The equipment grounding conductor must be green or bare. The ungrounded conductor's hot wires can be any color other than white, grey, or green. Proper identification of conductors is essential for safety and for troubleshooting electrical problems. Furthermore, it's important to maintain proper clearances around electrical equipment. The NEC specifies minimum clearances around electrical panels, transformers, and other equipment. These clearances are necessary to provide access for maintenance and repairs. Obstructions should not be placed in front of electrical equipment.